This is a reading from Toby Hemenway's Gaia's Garden, page 100. An oak tree. It's dawn. The first rays of sunlight strike the canopy of the oak, but most of the energy in these beams is consumed in evaporating dew on the leaves. Only after the leaves are dry does the sunlight warm the air within the tree. Above the oak, however, the air has begun to heat, and a cloud of just awakened insects swirls there. Below the canopy, it's still too chilly for insects to venture. The insects roil in a narrow band, sharply defining the layer of warm air above the tree. Together, the sun and the oak have created insect habitat, and with it, a place for birds who quickly swoop to feast on the swarm of bugs. In the cool shade of this tree, snow remains late into the spring, long after unprotected snow has melted. Soil near the tree stays moist, watering both the oak and nearby plantings and helping to keep a nearby creek flowing. Early miners in the West frequently reported creeks disappearing once they'd cut nearby forests for mine timbers. Soon the sun warms the humid, night-chilled air within the tree. The entrapped air dries, its moisture escaping to the sky to help form clouds. This lost moisture is quickly replaced by the transpiring leaves, which pump water from the roots and exhale it through puffy-lipped pores in the leaves called stomata. Groundwater, whether polluted or clean, is filtered by the tree and exits through the leaves as pure water. So trees are excellent water purifiers and active ones. A full-grown tree can transpire 2,000 gallons of water on a hot, dry day. But this moisture doesn't just go away, it soon returns as rain. Up to half of all rainfall over forested land comes from the trees themselves. The rest arrives as evaporation from bodies of water. Cut the trees and the rain disappears. Sun striking the leaves ignites the engines of photosynthesis, and from these green factories oxygen streams into the air. But more benefits exist. To build sugars and other carbon-based molecules that provide fuel and structure for the tree, the leaves remove carbon dioxide from the air. This is how trees help reduce the level of greenhouse gases. As the leaves absorb sunlight and warm the air within the tree, this hot, moist air rises and mixes with the drier, cool air above. Convection currents begin to churn and morning breezes begin. So trees help create cooling winds. But closer to the ground, trees block the wind. The oak's upper branches toss in the morning breeze, while down below the air is still. The tree has captured the energetic movement of the air and converted it into its own motion. Where does this energy go? Some scientists think that captured wind energy is converted into the woody tissue of the tree, helping to build tough but flexible cells. Trees make excellent windbreaks. A tree placed on the windward side of a house can substantially reduce heating bills. The morning breeze carries dust from the plowed fields of nearby farmland, which collects on the oak leaves. A single tree may have 10 to 30 acres of leaf surface, all able to draw dust and pollutants from the air. Air passing through the tree is thus purified and humidified as well. As air passes through the tree, it picks up moisture exhaled from the leaves, a light burden of pollen grains, a fine mist of small molecules produced by the tree, some bacteria, and fungal spores. Some of these spores have landed below the tree, spawning several species of fungus that grow symbiotically amid the roots, secreting nutrients and antibiotics that feed and protect the tree. A vole has tunneled into the soft earth beneath the tree in search of some of this fungus. Later, this vole will leave manure pellets near the oaks, inoculating them with the beneficial fungus. That is, if an owl who regularly frequents this oak doesn't snatch up the vole first. This tree's ancestors provided Native Americans with flour made from acorns, though most suburbanites wouldn't consider this use. Now, blue jays and squirrels frolic in the oak, snatching acorns and hiding them around this and neighboring yards. Some of these acorns, forgotten, will sprout and grow into new trees. Meanwhile, the animals' diggings and droppings will aid the soil. Other birds probe the bark for insects, and yet others depend on the inconspicuous flowers for food. Later in the day, clouds, half of them created by trees, remember, begin to build. Rain droplets readily form around the bacteria, pollen, and other microscopic debris lofted from the oak. These small particles provide the nucleation sites that raindrops need to form. Thus, trees act as cloud seeders to bring rain. As the rain falls, the droplets smack against the oak leaves and spread out into a fine film, coating the entire tree, all 10 to 30 acres of leaves, plus the branches and trunk, before a single drop strikes the ground. This thin film begins to evaporate even as the rain falls, further delaying any throughfall. Mosses and lichens on this old oak soak up even more of the rain. We've all seen dry patches beneath trees after a rain. A mature tree can absorb over a quarter inch of rain before any reaches the earth, even more if the air is dry and the rain is light. The leaves and branches act as a funnel, channeling much of the rain to the trunk and toward the root zone of the tree. Soil close to the trunk can receive 2 to 10 times as much rain as that in open ground, and the tree's shade slows evaporation, preserving this moisture. As the rain continues, droplets leak off the leaves and spatter on the ground. Since this tree drip has lost most of the energy it gathered during its fall from the clouds, little soil erodes beneath the tree. Leaf litter and roots also help hold the soil in place. Trees are supreme erosion control systems. The water falling from the trees is very different from that which fell from the sky. Its passage through the tree transmutes it into a rich soup laden with the pollen, dust, bird and insect droppings, bacteria and fungi collected by the leaves, and many chemicals and nutrients secreted by the tree. This nutritious broth both nourishes the soil beneath the tree and inoculates the leaf litter and earth with soil-decomposing organisms. In this way, the tree collects and prepares its own fertilizer solution. The rain ceases towards sundown and the sky clears. The upper leaves of the tree begin to chill as night falls and cold air drains down from the canopy, cooling the trunk and soil. But this chill is encountered by heat rising from the day-warmed earth, which warms the air under the tree. The leafy canopy holds this warmth, preventing it from escaping to the night sky, so nighttime temperatures are warmer beneath the tree than in the open. The leaves, however, radiate their heat to the sky and become quite cold, often much colder than the air. All these cold surfaces condense moisture from the air, and the resulting dew drips from the leaves and wets the ground, watering the tree and surrounding plants. Leaves can also gather moisture from fog. On a foggy day, the mist collects in such volume that droplets trickle steadily from the leaves. On arid but foggy coasts, tree-harvested precipitation can triple the average rainfall. By harvesting dew and fog, trees can boost available moisture to far beyond what a rain gauge indicates. As we gaze at this huge oak, remember that we're barely seeing half of it. At least 50% of the tree's mass is below the ground. The roots may extend tens of feet down and horizontally can range far beyond the span of the tree's branches. We've already learned how these roots loosen and aerate soil, build humus as they grow and die, etch minerals free from rocks with mild acid secretions, and with sugary exudates provide food for hundreds or even thousands of species of soil organisms that live with them. Roots bring nutrients from deep in the ground, and the tree converts them into leaves. When these leaves drop in the fall, carbon and minerals gathered from the immense volume of air and earth surrounding the tree are concentrated into a thin layer of mulch. Thus, the tree has harvested a diffuse dusting of useful nutrients, once sprinkled over thousands of cubic yards of soil and air, and distilled them into a rich, dense agglutination of topsoil. In this way, trees mine the sparse ores that surround them and build fertility and wealth. This wealth is shared with many other species which root and burrow, feed and build, all nourished by the tree's gatherings. But there is more. This tree's roots have threaded toward those of nearby oak trees and then fused with them. A tree's roots, researchers have shown, can graft with those of its kind nearby, exchanging nutrients and even notifying each other of insect attack. Chemical signals released by an infested tree prompt its neighbors to secrete protective compounds that will repulse the soon to invade bugs. If an oak is grafted to its neighbors, does it remain an individual tree? Perhaps trees in a forest are more like branches from a single subterranean tree than a group of individuals. The ways in which a single tree interacts with other species and its environment, then, are many. I've barely mentioned the swarms of insects that this oak supports: skull wasps and their relatives, beetles who tunnel into twigs and bark, and all manner of sucking and chewing bugs, and there are many insect predators. But there are the birds who feed on these bugs. And we shouldn't forget the myriad nearby plants that benefit from the rain and nutrients collected by the tree. Through this tree, we glimpse the benefits of ecological thinking. Instead of viewing a tree simply as something that looks nice or provides a single offering such as apples or shade, we can now begin to see how deeply connected a tree is to its surroundings, both living and inanimate. A tree transforms wind and sunlight into a variety of daily changing microclimates, harvests nutrients, builds soil, pumps and purifies air and water, creates and concentrates rain, and shelters and feeds wildlife and microbes. Add to this the better-known benefits for people: fruit or nuts, shade, climbing, and other fun for kids, and the beauty of foliage, flowers, or form. We start to see how tightly enmeshed is a simple tree with all the other elements in the landscape.